Hello everyone, welcome to the third episode of Programming with MrZemo. Today I will be teaching you guys simple logic using two buttons and four LEDs. And without further ado, let's shall begin the assembling process, shall we? The assembling process. This time it is a little more complicated. Don't be afraid, alright? So, buttons, resistors, these guys are 10,000 ohms. These guys. You can identify a resistor, how much ohm does it has by looking at the colors. Brown means 1, black means 0, orange means 10 times. So, sorry, 1,000 times. So, 1 is the first digit. This brown is the first digit. Black is our second digit. Brown corresponds with 0 and times 10. Black is 0 and corresponds with 1 times 1. Orange is 3 and corresponds by 1,000 times. I will put what are these? How can I identify them? Like, what are these stuff on the screen right about now? Actually, yep. I think, yeah, you can see LEDs. Just always, please note that these are 330 ohms and these are 10,000 ohms. Do not mix them to each other. They have similar colors and some cables and our Arduino. So it is extremely simple. We just adjust the camera. We use two buttons next to each other. Super simple. And our resistors 10k ones go to 0, ground. Why, you may say? You will see. Let me just say it actually. You make the reading from this bridge. You give the power here. This is the ground, and you get the reading right around here. So you have to connect your resistors to the ground here. It is extremely simple. So, one long red cable goes to 5 volts in on the Arduino Uno. It is right around here. You can see it is being labeled by that 5V connected to here. This red line is response that indicator of, like, you can use whatever you want. Maybe if you want, you can make it ground even, but it is a lot simpler when you color code them. So red is 5 volts and blue one is ground. Ground goes to ground pin on our Arduino Uno. So this was it. Main power grid done. Yep, it's that simple. Now let me just adjust the camera a bit because you guys couldn't see the button, so I'll reconnect one. So side by side, right around here, connect the resistors, these 10k ones, to the left leg. Left leg is here, the left one, this one, to ground. It goes to the ground because we get our readings from that one. And random cable to 5 volts, and I will connect one in the near future, don't worry. So red LED, green LED, blue LED, and yellow LED. These are the four main colors, four main LEDs we're going to use. Now at the resistors, the long leg is positive. You give power from here and you get access, or you get the used voltage from the shorter one. Let me just plug it back in. Resistors, as always, goes to the input energy inputs of our LEDs. Connect them as shown Nothing too complicated, just basic math, not math, but I will teach you guys math today. So, yep, that is a reality. Red goes to 9, pin 9. Try to utilize 9, 10, and 11 as much as you can while using LEDs because you will need it. The next video will about that, by the way. Just a little spoiler for you. If I remember making it. I most probably will, but no promises, alright? Green goes to the green. Color coding just makes life easier. Colors does not matter, as I said. And don't be stupid like me and connect them in order, not the way I just did. Connect the cables in order so it's easier to plug in the next one. And lastly, our yellow LED power out inputs to pin 12. Yep, pin 12 is our pin that we're going to use for our green LED. Um, Now, these buttons are used as inputs. What is an input, you may say? I will explain, don't worry. So, this one goes to port 2, but it starts with 0, 1, 2, so don't accidentally plug it into 0 or 1. Just straight go to the pin 1, pin 2. The next button goes to 3. We're going to use them as inputs. I will show you guys in the programming process. Green. We're just connecting the grounds now. Also the voltage, 5 volts in for buttons. It's extremely important. Don't miss that part. Yes, it looks extremely messy, I know, but that's just basics. I will, if it's possible, I will print out something from my 3D printer. Yes, I have a 3D printer. I'm not bragging, but I will use it. Trust me. Alright, the assembling process is complete. So, button 1 goes to 2, button 2 goes to 3, LED LED goes to 9, green 10, blue 11, and yellow goes to 12. I think I'm not sure if I said if I know my numbers. Let me just show you with this angle so you can see it a little better. And let's get programming, shall we? The programming process. So we always start with writing. I always start with writing what's the project we are doing. Logic 101. No, just kidding. It's not logic. Logic using and. Yep, this is what we use for and. And I will teach you guys, all right? It will be a little lesson. If if you couldn't hear me, I just adjusted the microphone a little bit. Logic using an I and. Yep. So from the start, we have to define which one is used for which. So integer, int, for short, led r is 9. You have to use equals here. Int led read is 10. This semicolon here, I will just show you. This semicolon is extremely important. If you do not say that, put that semicolon here, it just says that, okay, this line is not finished. Let me continue. And it just glitches. Thankfully, we have a little thing called verify. And I did not connect the port right now, board right now, so don't freak out. Everything is fine. We have just written 2 lines, all right? Int LED blue 11 semicolon and a LED yellow. This time well I accidentally said yellow to green in my last video. Sorry. Um, LED yellow. Okay. Integer button we write them. It's at least it's written like this in Turkish, so I will just call it button. Is button? Oh, you have to specify which button, by the way. Button one is pin two, integer. Button two, don't put that blank. Button two is three. That's our main code. So this is the hard part of this logic. Uh, all right. So integer. This is important. btn button for short. btn1 semicolon. Integer btn2 integer semicolon. I will explain you guys what are we doing with those. Int situation. So case one. Int case two. There's a code called switch case, but that's not our topic today. We are just going to, I'm just saying case for just convenience, all right? Integer case 4. So, what are all these stuff, you may say? It is extremely simple. Actually, you don't need them, but I will show you guys. So, without just first thing, we define what is what here, and setup is pin mode. Pin mode, LED R output. I will just go ahead and copy paste, but do not copy paste because I assume you're extremely new to this. And button. All right, LED red output, LED green output, LED blue output, LED yellow output. So this is the important button. Button one. We don't write in output here. We write input because we are reading data from a pin. When we read a data from a pin, we have to use input. Let let me just change it. Button to input. Yep, we just specified what is what here. So you have to put these lines in void loop. This is our logic part. So btn1 is equivalent. This usually, if you put 1 equals 0, it changes the integer's value. If you put 2, it says if something is equals to. I will show you guys that. I will use that. Button 1 is equal to digital read button 1. So why did you say read here? It's extremely simple. When you give out information, you said digital write or analog write, but our topic is not analog today. It will be the next episode if I remember making it. So read is when you get the information from a port. BTN2 is digital read button 2. Oh, I forgot something. So integer. These these guys are totally separate from conditions. Well, did I say conditions here? I don't know what I just referred to. C1. My memory is extremely bad. Forgive me. So integer. Situation 1. Integer. Situation 2. So these are extremely important. Situation 1 and situation 2. You will see. And make sure that they are equal to 0. You you might ask why? I will show you. btn1, btn2. So if is a logic, logic command. If something is present, something happens. If let's say situation one is you put two equals here, equivalence for example equivalency. If situation one is equal to zero, and this is and, these two and symbols mean and btn1 is 1. So I think I forgot to tell you guys about this. When you say digital read, it gives either 1 or 0. 1 is high, 0 is low. If btn1 is 1. So right off the bat, we are going to change s1 is equal to 2. Sorry, s1 is equal to 1. Why? So I will explain at the end. Don't worry. S1 is 1. Or S1 is done if S1 is equal to 1 and btn1 is equals to 0. Let me just correct that one. All right. If btn1 is when you pull our finger, when we push, this is when we push, this is when we pull our finger. So if you don't know how to put these guys, uh, alt alt alternate something, I don't alt gr 7 is the left side and alt gr 0 is the right side if you may need it. Thank you later. So if situation 1 and situation is 1 and button is 0, do define situation 1 as 2. If situation 1 is equal to 2 and btn1 is 1. When we push again, it means parenthesis s1 equals to 3. And when you pull our fingers, if s1 is equivalent to 3, and if we pull our finger, button 1 equals to 0, revert s1 back to 0. This we have just created a loop here. A loop we command a step. This is one step, this is second step, third, and fourth. So if situation one is default 0 and you push the button, situation one goes to 1. If situation one is 1 equivalent to 1 and we contract our finger, situation one goes to 2. So that no information is lost. 2 is if it is equivalent to the second time we push, we give 3. If it's 3 and we contract our finger, it is 0 again. So I will just go ahead and copy paste this part for don't be stupid. Place one blank here, situation 2 and button 2. Yep, button 2 is digital read button. Change these zeros and these S1s with S2 and buttons with button 2, ETN2. Fairly simple. There's actually easier ways of doing this, but I started this, so I will just go ahead and continue like this. Button 2, S2 is 0. All right, so this was a part of our main program. This was just the input part. Now, the horrible output part. If S1 is equivalent to 1 or 2, so I cut this part here and start explaining you guys basic logic. Brief explanation of how AND works. Yep, I am teaching you guys logic using Microsoft Paint. Yes, I'm a madman. So, two inputs, A and B. There are four possible combinations using AND. 1, 1, 1, 0. Oh, that's a horrible 0. 1, 0, oh, 1, 0, 0, 1, 0, 0. Those are two possible combinations we can get from A and B. The combinations we can get is resembled by 2 in the power of to the power of n. What is n? The amount of variables we have. I hope I written that one right. It looks horrible. It does look horrible. So the end is pretty simple, but the yep, and is pretty simple. We are not using ants. Oh yes, logic. Don't mind me, friends. I'm just a little tired at this point. Only a one. This is situation one, situation two, situation three, and situation four. These are four situations we will get. So 1, 2, 1, 2, 3, 4, 1, 2, 3, 4. 2 to the power of n is the amount of possibilities we can have. And that was basically how logic works. And let's continue programming, shall we? Yep, this was our basic logic. And it, as you can see, two inputs means four outcomes for using AND. So S1 is equivalent to 1 or S1 is equivalent to 2. We use a parenthesis here so it doesn't get confused. And parenthesis S2 is equivalent to 1 and S2 is equivalent to 2. This is the main code, don't freak out. Normally, I would just go ahead and use case 1 for explaining you guys, but I will just delete this part. These are not important. So, if we pushed both of buttons and pulled our finger, or I don't, does not matter. If we pulled our finger, case 1 will happen. And this is LED. Red. No, no, it's not written like this. Digital, right? LED, red, 1 or high. Does not matter. On high, copy paste, copy paste, copy paste, does not matter. But do not copy paste. Write all of them. Let's green, let's blue, let's yellow. All of them are 1. 4 outputs, as I said. I will just go ahead and copy paste because 4 outcomes, right? Yep. So don't turn all of them on. Only turn red on. Low, the rest are low. So S1 is positive and S2 is negative. For this one, just going to use zeros. Oh, don't put and here. Put these two symbols. I just remembered. You use these two. Those two symbols, which means or. Yep. If two of them cannot be possible at the same time, so we gotta use or here. Or, but keep this and because it is required here. Or and or. Yep. If S1 is equal to 1 or 2, and S2 is equal to 1 or 2. S2. Okay. Don't be silly. Don't make the mistakes I make. I am not as smart as you may think. So S1 is positive, S2 is negative for this one, 0 and 3. Let turn only the what did I just do here? Turn only the LED green on for this one. Only turn on the green. So if the second one is positive and the first one is negative, which is resembled by 0 and 3, only turn on blue LED. And if both of them are negative, you just only turn the yellow LED on. Fairly simple, isn't it? Boop, boop, and yep. Select board. First of all, connect your Arduino to your PC. And here, yep, just connected it. Communication and Uno. If you're using Nano, use Nano. Mega, does not matter. Little check mark if our program is correct and done compiling, which means it has no issues. It's supposed to have no issues though. So the upload is done. And it should be working. Let me just double check. Um, I did a little mistake somewhere. That green. Did I? Oh yes. No. Yep. This is my mistake. Sorry. LED yellow is on. Done uploading. Check. So it seems to be working, but for just to be safe, I will just start a serial begin. Nine. This this is what we use for reading in data. Serial begin in 9600. This can change. All right. If After all of these ifs, use serial point writes. No, print line. No, just print. This process took a little longer than I expected. So as it turns out, we have to use C1 and C2 and C3 and C4. So first case, C C1 is equal to 1. C2 is 0. C3 is 0. C4 is 0. I'll just go ahead and copy paste. Forget to fix them. Case 2. and fairly simple. Serial print C1, serial print. Just go ahead and copy paste. Whoop, whoop, whoop. Change the last one to print line because it will start on a new line after that one. C2, C3, and C4. Upload it yet again to the monitor. Okay, so phase one. Um, zero begin 6,000. Oh, my PC cannot read. All right, all right, all right. Everything is fine. Everything is working. It's supposed to be working. Did I not? Up. Reboot the system. Zero. Is why it's not that working? Button one, button two. Did I change those to button two? All right, situation two. Oh, yeah. Little mistake. My bad. Troubleshooting is extremely important. Don't forget to do that. All right. Um, situation two, situation two, situation two, situation two, situation two. S1, S1, S2, 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 S2. All right, it is working. Yep, it is working. I will turn on the webcam.
Logic was pretty simple. If none of these are positive, resembled by yellow LED. Left one is resembled by yellow. When we turn it off, it goes back to yellow. Click it again. Click the right one this time and goes to blue. Oh, my PC crash! No, my PC just crashed. Um, I hope it did the recording because that was pretty important. Let me just continue. If both of them are positives, you get the red light. That was it. That's our project. Thank you um, for bearing my horrible English yet again. I think I got better this time. Alright, see you friends in a later episode of programming. This was episode 3. Now, please don't forget to like and subscribe, and if possible, share, because I need money. Money talks.